Hello friends, let us try a question based on kinematics in this video. In the question it is given that a bowman is riding on a horse which is moving with a speed of 2 meter per second along a straight road. He now aims at his enemy which is moving perpendicular to the road at a speed of 2 meter per second. Now at the instant when he fires the arrow, the line joining the man and his enemy makes an angle of 45 degree with the road. Now we have to find the angle with the road at which he should aim in order to hit his enemy. So we have to ultimately find the value of this total angle alpha. This is the angle where he should aim his bow in order to hit the enemy. The muzzle velocity of arrow given the problem is 5 meter per second, and we have to neglect the effect of gravity. So according to the problem, it is given that the person is moving with a speed of 2 meter per second and his enemy is present somewhere over this point at an angle of 45 degree with the road. So this angle which is mentioned in the problem is 45 degree. Now in frame of reference of the enemy, let us now shift our focus in frame of reference of enemy. Since his enemy is moving with a speed of 2 meter per second, so in frame of reference of his enemy, it will appear to us that the person is again moving at a speed of 2 meter per second in downward direction with the help of relative motion. Now I am assuming that in order to strike his enemy, he aims his arrow with speed v, the muzzle speed of which is given in the problem. He aims his arrow with speed v at an angle of theta with this line. Now on resolving all the velocities which are given in the problem along the direction of these two axes, that is x and y axis, I am considering these two axes as x and y axis. We can directly resolve this velocity into two components. Let me redraw the axis for further simplifying this problem. I am considering these two axes and as x and y axis. V on resolving along this direction can be written as v cos theta, and its second component will be equal to v sin theta. Similarly, we can resolve this velocity of 2 meter per second, which will give us the value of 2 cos 45 degree and 2 sin 45 degree. Again, this third velocity vector 2 can now be resolved along these two axes, which will give us the value of 2 sin 45 degree, and the second component will be 2 cos 45 degree. We now want the resultant of all these velocities to be along y direction. Since we want the resultant to be along y direction, that is directly aiming towards enemy, this is only possible if the x component of all these velocities will cancel each other. That is, we can say that the value of v sin theta has to be equal to the sum of these two velocities. So from here we can write the value of v sin theta should be equal to 2 sin 45 degree plus 2 sin 45 degrees, which on further simplification will give us the value of 3 equals to 5 sin theta, where I have substituted the value of v which is given in the problem. As you can see, the value of v was already mentioned in the problem. So I have already substituted this value and simplified this expression. So this angle comes out to be equal to 37 degree. But since we have to find the angle with the horizontal, so we can say that the angle made by the arrow with the horizontal is 45 degree plus theta. So our final answer has to be, with the horizontal the angle will be alpha, which is equals to 45 degree plus theta, which is equals to 82 degrees. This is our final desired result. Thank you.